So now here we can see that there are three terms. Okay, now when we differentiate the first term, what we will get? R into x minus lambda the whole raised to r minus 1 into minus 1. Okay, lambda raised to x by x factorial e raised to minus lambda plus summation x is equal to 0 to infinity x minus lambda the whole raised to r. Now this term, second term, I'm going to differentiate the second term, x into lambda raised to x minus 1 divided by x factorial e raised to minus lambda plus summation x is equal to 0 to infinity x minus lambda raised to r, lambda raised to x by x factorial e raised to minus lambda into minus 1. So this is what we get when we differentiate this term. Now our next step will be, what I'm going to do is, I'm going to keep this first term as it is, okay, and I'm going to club this two terms, that is the second and the third term. So let's see what we'll get. So the first term, as I said, I'm keeping it as it is, r into x minus lambda the whole raised to r minus 1 minus 1 lambda raised to x by x factorial e raised to minus lambda. Now the second term, summation x is equal to 0 to infinity. Now the second term and the third term we are going to combine. So I'm going to take outside x minus lambda raised to r, lambda raised to x minus 1 by x factorial e raised to minus lambda. So these are the terms I am going to take outside. So let's see what I get. X minus lambda raised to r, lambda raised to x minus 1 divided by x factorial e raised to minus lambda. Okay, so in the first term what is remaining is x. So I write x over here minus. Now in the second term what is remaining, x minus lambda raised to r is taken outside, lambda raised to x minus 1. So here I have only lambda raised to x. So if I take lambda raised to minus 1 outside, what is that I get over here? Okay, so then x factorial, if I take x factorial outside and e raised to minus lambda, that is also the thing that I have taken outside, then there is minus. So here what I have done is, I have taken all the common terms outside, and then in the brackets I got for the first term, only the first, the remaining thing is x, so I wrote it over here. And in this case, in the second term, you have what? Your lambda raised, a lambda over here, because you have only your lambda raised to x here, and I have taken outside from the third term lambda raised to x minus 1. So you have a lambda here, and there is a negative 1 sign over here, so I just put a negative sign in between x and lambda. So that is how you got these two terms. Okay, now again I am going to rearrange this. Here I am going to combine this r and minus 1, so minus r is taken outside. What is the other things that I have with me? X minus lambda raised to r minus 1, lambda raised to x by x factorial e raised to minus lambda. So what is it? It is nothing but your mu r minus 1 plus. Now here I am going to add a lambda, and so when I multiply a lambda, not add, multiply a lambda, naturally I will have to divide by lambda. Okay, so when I multiply a lambda, my intention is just to cancel this lambda and this lambda raised to minus 1 over here, so that I only get the lambda raised to x, so that I can write it as what? Summation x is equal to 0 to infinity x minus lambda raised to r, and you have an x minus lambda over here, so you can write that as x minus lambda raised to r plus 1. Then lambda raised to x minus 1, I have multiplied a lambda over here and divided a lambda over here. So you just consider this numerator part and this one. So you get lambda raised to x divided by x factorial e raised to minus lambda. Again there is a lambda just in the denominator, so that I am going to write it over here. Okay, so finally what I get is d mu r divided by lambda is equal to minus r mu r minus 1, then plus 1 by lambda, and what is this term? Mu r plus 1. So just look at your statement and rearrange these this final answer that you get, so that you get what is written in your statement. So that is how you find the recurrence relation of central moments in case of a Poisson distribution. Now we will have a look at the mode of the Poisson distribution. Now let x be the mode, then we will consider two inequalities to find out the mode of a Poisson distribution. The first inequality is f of x minus 1 less than or equal to f of x. So let's have a look at the first inequality, that is f of x minus 1 less than or equal to f of x, which implies lambda raised to x minus 1 e raised to minus lambda by x factorial less than or equal to lambda raised to x e raised to minus lambda divided by x factorial. Sorry, this is x minus 1 factorial. Okay, so instead of x factorial, I can write x into x minus 1 factorial. Okay, so that this term, and here in the denominator x minus 1 factorial get cancelled. And also you have this lambda raised to x and lambda raised to x gets cancelled, which implies what, 1 by lambda less than or equal to, not 1 by x. So which implies what, you take this over here, what you get, x less than or equal to lambda. So this is what we get from the first inequality. Now I am going to term it as A. Okay, now let's have a look at the second inequality. This is the second inequality, and now let's look what we will get. Lambda raised to x plus 1 e raised to minus lambda divided by x plus 1 factorial less than or equal to lambda raised to x e raised to minus lambda divided by x factorial. Now instead of this x plus 1 factorial, you can write what, x plus 1 into x factorial. Okay, so again x factorial get cancelled, this and this gets cancelled, lambda x and lambda x get cancelled. What is the remaining thing? Lambda divided by x plus 1 is less than or equal to 1. So what will you get, which implies lambda less than or equal to x plus 1, which implies lambda minus 1 less than or equal to x. Now this is your inequality B. Okay, now from inequality A and inequality B, what can you, when you combine A and B, what will you get? Combining A and B, you get lambda minus 1 less than or equal to x less than or equal to lambda. So therefore, in a Poisson